July 1944, Normandy, France. Oberingenieur, chief engineer. Klaus Richter had been with the Wehrmacht's weapons testing division since 1941. His job was to examine captured enemy equipment, Soviet tanks, British artillery, American rifles, anything that could provide intelligence about enemy capabilities. Klaus was 52 years old. He'd been an automotive engineer before the war, designing trucks for Daimler-Benz. When war started, the Wehrmacht recruited him. His expertise in mechanical engineering made him valuable. By July 1944, Klaus had examined dozens of Allied vehicles. He knew their strengths and weaknesses. He understood what made them effective or ineffective. And he'd developed a professional respect for Allied engineering, even if he couldn't say so publicly. On July 18th, Klaus received orders to report to a testing facility near Paris. The orders were brief. Captured American tank requires immediate evaluation, technical assessment priority. Klaus arrived at the facility on July 20th. In a secured warehouse, he saw what he'd been summoned to examine, an M4 Sherman tank. The Sherman wasn't new to Klaus. He'd seen battlefield reports. He'd read intelligence summaries. The Sherman was the primary American tank. They were building thousands of them. German tankers had been fighting Shermans since North Africa in 1943, but Klaus had never examined one up close, never studied the engineering, never opened the engine compartment to see what made it work. The Sherman in front of him was damaged, but intact. It had been captured near Caen. American crew had abandoned it after hitting a mine. German forces recovered it before it could be destroyed. Klaus walked around the tank slowly, making observations, taking notes. The first thing he noticed, the Sherman was big. Not as big as a German Tiger tank, but substantial, about 30 tons, roughly the same size as a Panzer IV, Germany's standard medium tank. The second thing he noticed, the Sherman looked simple, not crude, not poorly made, but simple, clean lines, standardized components, nothing excessive, nothing unnecessary. A Wehrmacht major accompanied Klaus, Major Heinrich Weber. He'd fought in North Africa and Russia. He knew tanks from a combat perspective. "Herr Oberingenieur," Heinrich said, "I've fought against these tanks for over a year. They're inferior to our Panthers and Tigers. The armor is thin. The gun is weak. Our tankers call them Tommy Cookers. They burn easily." Klaus nodded. He'd heard the same reports. Shermans had thinner armor than German heavy tanks. The 75mm gun was less powerful than the German 88mm. In direct combat, a Panther or Tiger could destroy a Sherman from ranges where the Sherman couldn't effectively return fire. "That's all true," Klaus said. "But tell me, Major, how many Shermans have you seen on the battlefield?" Heinrich thought about it. "Hundreds, maybe thousands. They're everywhere. For every German tank, the Americans have 5 Shermans." "And how many German tanks do you see on the battlefield?" Heinrich's expression darkened. "Not enough. Never enough. We lose tanks and cannot replace them quickly. The Americans lose tanks and more arrive the next day." Klaus made a note. Quantity. That was part of the equation, but there had to be more to it than just numbers. "Major, I'll need several days to properly examine this vehicle. I want to understand not just what it does, but how it's built. Can you arrange for mechanics to assist me?" "Of course, Herr Oberingenieur, whatever you need." For the next week, Klaus and a team of 3 mechanics systematically disassembled the Sherman. They removed hatches, opened access panels, pulled the engine, examined the transmission, studied every component. What Klaus found would change his understanding of tank design forever. Day 1 of the examination focused on the engine. The Sherman used a Continental R975 radial engine. It was an aircraft engine, modified for tank use. 9 cylinders arranged in a radial pattern, air-cooled, gasoline-powered. Klaus had expected something sophisticated. American industry was advanced. Surely they'd developed specialized tank engines with cutting-edge technology. But the R975 wasn't cutting-edge. It was proven technology. The engine design dated back to the 1930s. It had been used in aircraft for years before being adapted for tanks. One of Klaus's mechanics, Sergeant Otto Fischer, examined the engine and said, "Sir, this engine is old technology. Why would the Americans use an outdated aircraft engine in their primary tank?" Klaus thought about it. Because it works, because it's reliable, because they can produce it in quantity. This engine wasn't designed for tanks, but it doesn't need to be. It provides sufficient power. It's proven. And most importantly, every mechanic who worked on aircraft engines can now service tank engines. That's not primitive. That's brilliant. Klaus made detailed notes. The engine produced 400 horsepower, not impressive compared to German tank engines, but sufficient for the Sherman's weight and purpose. And the engine was simple, accessible, easy to maintain. Day 2 focused on the transmission. German tanks used sophisticated transmissions, multiple gears, precise engineering. They were mechanical marvels when they worked. But they were also complex, difficult to maintain, easy to damage if not operated correctly. The Sherman's transmission was different. It was a modified truck transmission, 5 forward gears, 1 reverse, simple synchromesh design, nothing fancy. Otto looked at the transmission and laughed. "Sir, this is a truck transmission. They put a truck transmission in a tank." Klaus examined it more carefully. Yes, they did. And look at this." He pointed to mounting points. "The entire transmission can be removed and replaced in under 3 hours. The mounting system is standardized. Any Sherman transmission fits any Sherman. That's not inferior engineering. That's superior logistics." Klaus compared it mentally to German tanks. A Panther's transmission required specialized tools and skilled mechanics. Replacement could take days. If a transmission failed in combat, the tank was often abandoned because field repair was impossible. The Sherman's transmission could be swapped out in a field workshop in an afternoon. Day 3 examined the armor. German tankers were right. Sherman armor was thinner than German heavy tanks. The front armor was 51mm. German Panthers had 80mm front armor. Tigers had 100mm. In a direct engagement, the Sherman was vulnerable. But Klaus noticed something else. The armor wasn't just thinner, it was simpler to produce. Flat plates, simple angles, welded construction that could be done quickly in factories. German tanks used complex armor schemes, interlocking plates, sophisticated angles, difficult welding that required skilled workers. Each German tank took weeks longer to build than necessary because of armor complexity. Klaus calculated production time. A Sherman could be built from raw materials to finished tank in about 8 weeks. A Panther took 16 weeks. A Tiger took 24 weeks. That meant for every Tiger Germany built, America built 3 Shermans. For every Panther, America built 2 Shermans. Day 4 studied the tracks and suspension. The Sherman used a suspension system called HVSS, horizontal volute spring suspension. It was, again, simple. Springs and wheels, nothing sophisticated, but it was effective and reliable. German tanks used torsion bar suspension, more advanced theoretically, but also more complex and harder to maintain. Otto pointed out something interesting. "Sir, look at these tracks. They're rubber padded. That reduces ground pressure and improves traction. But more importantly, these tracks last longer than our metal tracks. Rubber padding protects the metal underneath." Klaus examined the tracks. They showed wear, but not excessive wear. This tank had clearly seen combat use, but the tracks were still serviceable. "How many kilometers do you estimate these tracks have traveled?" Klaus asked. Otto measured the wear. "Maybe 2,000 kilometers, maybe more. German tracks typically need replacement after 1,000 kilometers." Klaus made another note: track longevity. That meant fewer replacements, fewer supply chain demands, more operational time. Day 5 examined the interior. Klaus climbed inside the Sherman. The interior was cramped, 5 crew members in a relatively small space. But it was organized, logical, everything had a place. The most striking feature was the ammunition storage. The Sherman used wet stowage. Ammunition was stored in liquid-filled containers that would suppress fires if the tank was penetrated. This was revolutionary. German tanks stored ammunition dry. If a tank was hit and ammunition ignited, the entire tank often exploded. German tankers called it brewing up. The tank would burn so intensely that crew survival was nearly impossible. The Sherman's wet stowage significantly reduced fire risk. If the tank was penetrated, the liquid would suppress ammunition fires, giving the crew time to escape. Klaus asked Heinrich about this. "Major, have you noticed that American tank crews seem to survive more often than German crews?" Heinrich nodded. "Yes, when we destroy a Sherman, often the crew escapes. When we lose a Panther or Tiger, usually the entire crew dies. I'd assumed American crews were better trained to abandon tanks quickly." "No," Klaus said. "It's the wet stowage. Their tanks don't explode as violently. The crew has time to escape. That's not luck. That's engineering." By the end of day 5, Klaus had compiled over 60 pages of notes, and he'd reached a conclusion that troubled him deeply. Klaus requested a meeting with Major Heinrich and the facility commander, Colonel Ludwig Graf. They met in the colonel's office on July 26th. Klaus presented his findings systematically. "Gentlemen, I've completed my examination of the American M4 Sherman tank. My conclusions are as follows. First, the Sherman is not technically superior to German tanks in terms of armor, weaponry, or performance. In direct combat, a Panther or Tiger has significant advantages. However, and this is crucial, the Sherman is superior in every other aspect that matters for sustained warfare. The Sherman is more reliable. The engine design is proven and robust. Failures are rare. When failures occur, repairs are simple and quick. The Sherman is easier to maintain. Components are standardized and accessible. A crew with basic tools can perform most maintenance in the field. The Sherman is faster to produce. Simplified design and standardized components mean American factories can build Shermans in 1/3 the time it takes us to build equivalent tanks. The Sherman is easier to transport. It's lighter than German heavy tanks. It can cross bridges that Panthers and Tigers cannot. It can be shipped more efficiently. The Sherman has better crew survivability. Wet stowage and multiple escape hatches mean American crews often survive tank destruction. Our crews usually do not. In summary, the Sherman is not the best tank on the battlefield, but it is the most practical tank, and in industrial warfare, practical beats perfect. Colonel Ludwig listened carefully. Then he asked, "Are you saying the Americans have out-engineered us?" Klaus chose his words carefully. "No, sir. I'm saying the Americans have engineered for different priorities. We've engineered for performance. They've engineered for reliability, producibility, and sustainability. Both approaches are valid, but in a long war, their approach is more effective." Heinrich spoke up. "Herr Oberingenieur, you said the Sherman is easier to produce. How much easier?" Klaus consulted his notes. "Based on design analysis and intelligence reports, I estimate American factories can produce 3 Shermans in the time it takes us to produce 1 Panther, 5 Shermans for every Tiger." The room went silent. Colonel Ludwig stood up and walked to a map on the wall. It showed the Western Front. American forces were advancing. German forces were retreating. 3-1, Ludwig said quietly. "We knew the Americans had numerical superiority, but I didn't understand why. Now I do. They're not just producing more tanks. They're producing tanks that can be manufactured quickly, maintained easily, and kept operational longer than ours." Klaus nodded. "Exactly, sir. The Sherman represents a different philosophy of warfare. We build tanks for tactical superiority, better armor, better guns, better performance. The Americans build tanks for operational superiority. More tanks, more reliable tanks, more sustainable logistics. And which philosophy wins wars? Ludwig asked, though he clearly already knew the answer. In a short war, tactical superiority matters. In a long war, operational superiority matters more. Gentlemen, this is a long war, and it's becoming longer every day. Ludwig sat down heavily. I need to report this to Berlin. They need to understand what we're facing. Klaus prepared a formal report. It took him 3 days to write. The report was 38 pages long, with technical drawings, photographs, and detailed analysis. The conclusion was unambiguous. The American M4 Sherman represents a paradigm shift in armored vehicle design. The Sherman prioritizes reliability, maintainability, and mass production over raw performance. This design philosophy, combined with American industrial capacity, has created a tank that is individually inferior to German designs, but collectively superior in operational effectiveness. Unless Germany can match American production capacity or significantly disrupt American supply chains, German armored forces will continue to face overwhelming numerical disadvantages that tactical superiority cannot overcome. The report was sent to Berlin on August 3, 1944. It was read by several senior officers. Some agreed with Klaus's assessment, others dismissed it as defeatist thinking. But one officer, General Heinz Guderian, Inspector General of Armored Troops, read the report carefully. He wrote a response that was circulated to senior command. Guderian wrote, "Oberingenieur Richter's analysis is correct and deeply concerning. We have been building tanks as individual weapons. The Americans have been building tanks as industrial products. We create masterpieces. They create systems. In modern warfare, systems defeat masterpieces. We must adapt our production philosophy immediately or face continued numerical inferiority that will prove decisive." But it was too late. Germany's industrial capacity was already overstretched. Factories were being bombed, resources were scarce, skilled workers were depleted. The time to adapt had been 1942. By 1944, Germany could only continue with existing designs and hope for miracles that wouldn't come. What Klaus Richter had discovered, what troubled him so deeply, was that American tank design wasn't accidental. It was intentional, carefully planned, based on a completely different understanding of modern warfare. American tank designers had studied World War I. They'd learned that wars were won not by superior weapons, but by superior logistics and sustainability. An army that could keep fighting, keep supplied, keep operational, that army would eventually win. In 1940, when America began designing what would become the Sherman, the design team had specific priorities. Priority 1, reliability. The tank must operate for extended periods without mechanical failure, simple proven components, easy maintenance, field repairable. Priority 2, producibility. The tank must be manufacturable in large quantities by factories that had never built tanks before. Standardized parts, simple assembly, minimal specialized tooling. Priority 3, transportability. The tank must be shippable across oceans, must fit on standard cargo ships, must be light enough to cross most bridges, must be deployable globally. Priority 4, crew survivability. The crew must have reasonable chances of surviving tank destruction. Multiple escape hatches, fire suppression systems, ergonomic interior design. Priority 5, combat performance. The tank must be capable of defeating most enemy tanks in combat situations. Notice that combat performance was priority 5, not priority 1. American designers understood that a tank that couldn't reach the battlefield, couldn't be maintained or killed its crew after one hit was useless. regardless of how powerful its gun was. German designers had reversed these priorities. Combat performance was first, everything else was secondary. Both approaches were logical, but they led to completely different tanks. The Sherman could travel 160 kilometers on a full tank of fuel. It could operate for 3,000 kilometers before requiring major maintenance. It could be repaired in the field with basic tools. It could cross bridges rated for 30 tons. It could be produced at a rate of 2,000 units per month across multiple factories. The Panther had better armor and a better gun, but it could only travel 110 kilometers on a full tank. It required major maintenance every 500 kilometers. It required specialized tools for most repairs. It weighed 45 tons, too heavy for many bridges. Production peaked at 300 units per month. The Tiger was even more extreme, powerful, heavily armored, veered by Allied tank crews, but it could only travel 85 kilometers on fuel. It required constant maintenance. It was so complex that even minor repairs often required factory support. It weighed 54 tons, far too heavy for most European bridges. Production never exceeded 100 units per month. Klaus understood all of this intellectually, but understanding it emotionally was different. Germany had spent decades building a reputation for engineering excellence. German cars were the best. German machinery was the finest. German precision was unmatched. And here was America, a country Germans had sometimes dismissed as commercially crude, more interested in profit than perfection, building tanks that were more effective for sustained warfare than German masterpieces. It wasn't that American engineers couldn't build complex tanks. They could, but they chose not to. They chose simplicity. They chose reliability. They chose sustainability. And they were winning because of it. In September 1944, Klaus was sent to the Western Front, not to fight. He was too old and too valuable as an engineer, but to observe, to understand how tanks performed in actual combat conditions rather than testing facilities. He spent 3 weeks with panzer units near the German border. What he saw confirmed everything his analysis had suggested. German tank units were often immobilized, not by combat damage, but by mechanical failures. Panthers breaking down after long marches, Tigers requiring constant maintenance, tanks abandoned because fuel was unavailable or replacement parts couldn't be delivered. An experienced Panzer commander, Major Karl Hoffmann, explained the reality. Herr Richter, on paper, my unit has 18 Panthers. In reality, on any given day, maybe 12 are operational. The others are broken down, waiting for parts, or requiring maintenance. And that's actually good. Some units report only 50% operational readiness. The Americans, from what we've observed, their operational readiness is over 80%. Their Shermans just work. They keep running. When one breaks down, they replace it or repair it quickly and get it back in action. Last week we destroyed 3 Shermans in an ambush. We celebrated, 3 enemy tanks eliminated. But 2 days later we encountered the same American unit. They had 3 replacement Shermans, new tanks, fresh crews, like we hadn't even hurt them. Meanwhile, we lost 1 Panther last month to engine failure. 1 tank, still waiting for a replacement, won't get one. There are no replacements available. Klaus watched a maintenance crew working on a Panther. They'd been working for 6 hours, trying to replace a final drive, the component that transferred power from the transmission to the tracks. It was a complex job, requiring specialized tools and experienced mechanics. Klaus asked, "How long would this repair take on a Sherman?" The senior mechanic, a sergeant who'd worked on captured Shermans, said, 2 hours, sir, maybe less. The Sherman's final drive is modular. Remove 6 bolts, slide out the old unit, slide in the new one, reinstall the bolts. Simple. And on the Panther? 12 hours if everything goes well. 18 hours if we encounter complications, and we almost always encounter complications. That evening, Klaus sat with Major Hoffmann and several other officers. Over schnapps, rationed but still available, They discussed the situation honestly, away from official reports, away from propaganda. "We're losing," one captain said bluntly, "not because our soldiers aren't brave, not because our tactics are wrong, but because we can't sustain this. We can't replace losses. We can't maintain equipment. We can't compete with American logistics." Another officer disagreed. "Our tanks are superior. One Panther can destroy 5 Shermans." "Maybe," Hoffman said, "but the Americans bring 10 Shermans. And while we're destroying 5, the other 5 are destroying us. And next week they have 10 new Shermans. We have nothing. Numbers matter. Reliability matters. Sustainability matters. And we're losing on all 3 counts." Klaus shared his findings from the Sherman examination. He explained the design philosophy, the focus on reliability over performance, the emphasis on producibility. The officers listened in silence. Finally, one major asked, "So you're saying we've been building the wrong tanks?" Klaus thought carefully before answering. "No, I'm saying we've been building tanks for a different kind of war, a short war. A war where tactical superiority matters more than operational sustainability. But this war isn't short, it's long. And in a long war, the Americans' approach is proving more effective." "Can we change?" someone asked. "Can we start building tanks like the Americans?" Klaus shook his head. "Not anymore. That decision should have been made in 1942. Now, our industrial capacity is too damaged, our resources too limited, our supply chains too disrupted. We're committed to our current designs, and we'll have to live with the consequences." The room fell silent. These were professional soldiers. They understood what Klaus was saying. The war was lost, not next month, not next year, but eventually, inevitably, because Germany couldn't sustain a long war against an enemy with superior production capacity and more practical equipment. Klaus Richter survived the war. He was captured by American forces in March 1945. He spent 2 years in a POW camp. During that time, American intelligence officers interviewed him extensively about his work examining captured equipment. One interview in November 1945 was particularly revealing. An American colonel, an engineer himself, asked Klaus, "What did you learn from examining our Sherman tank?" Klaus answered honestly, "I learned that American engineering philosophy is fundamentally different from German philosophy. We engineer for perfection, you engineer for practicality. Both have merits, but in industrial warfare, practical defeats perfect." Did that surprise you? Yes. I'd been taught that German engineering was the best in the world, that our precision and sophistication were unmatched. Examining the Sherman forced me to reconsider what best means. Is the best tank the one with the thickest armor and biggest gun? Or is the best tank the one that gets to the battlefield, keeps fighting, keeps its crew alive, and can be replaced when destroyed? The Sherman wasn't perfect, but it was perfectly suited for the war you were fighting. The colonel nodded. "You know, we had debates about this. Some of our generals wanted heavier tanks, better armor, bigger guns. We could have built tanks to match your Panthers or Tigers. But we chose not to. We chose the Sherman because it fit our strategy, numerical superiority, operational sustainability, and global deployability. Was it the right choice?" Klaus didn't hesitate. "Yes, absolutely yes. You won the war. That's the only metric that matters. The Sherman was the right tank for America's way of war." After his release in 1947, Klaus returned to Germany. He worked for Mercedes-Benz, helping rebuild Germany's automotive industry. He occasionally gave lectures at technical universities about engineering philosophy. In a 1958 lecture at Technical University of Munich, Klaus discussed his wartime work examining the Sherman. "Young engineers," he said, "often believe that the best solution is the most sophisticated solution, the most complex, the most technically advanced. I believed that once. Then I examined an American tank that taught me otherwise. The Sherman wasn't sophisticated. It used old engine technology. Simple transmission, straightforward armor, nothing cutting edge. yet it was one of the most effective weapons of World War II. Why? Because it was designed for the right priorities. Remember this, engineering is not about building the most complex solution. It's about building the right solution for the problem at hand. Sometimes that means simplicity. Sometimes that means reliability over performance. Sometimes that means producibility over perfection. Germany lost World War II for many reasons. But one reason, one important reason, was that we engineered for perfection when we should have engineered for practicality. We built masterpieces. America built systems, and systems won. In 1965, Klaus was invited to America. The Society of Automotive Engineers wanted him to speak at their annual conference. The topic, Lessons from Wartime Engineering. Klaus accepted. It was his first trip to America. The organizers arranged for him to visit the Detroit Tank Arsenal, one of the factories that had produced Shermans during the war. The factory had returned to automotive production, but it still maintained a small museum with a restored Sherman. Klaus stood in front of that Sherman for a long time. 21 years after he'd first examined one in France. He'd spent a week studying every component, making notes, trying to understand why this simple tank was so effective. Now, standing in the factory where thousands had been built, he finally understood completely. It wasn't just the tank, it was the entire system, the factory, the supply chain, the training programs, the maintenance doctrine, the replacement system. The Sherman was just one component of a comprehensive industrial warfare machine. Germany had built excellent tanks, America had built an excellent system, and in modern warfare, systems always beat individual excellence. The Sherman tank served in over 50 countries after World War II. Some remained in active service until the 1990s, 50 years after production began. That longevity was testament to the design's fundamental soundness. Total production, 49,234 units. More than all German tank production combined, more than the Soviet T-34 in terms of variants and modifications. The Sherman wasn't perfect. American tank crews knew its limitations. They called it the Ronson because it lit on fire easily, at least in the early versions before wet stowage was introduced. They knew German tanks had better armor and bigger guns, but they also knew the Sherman would get them to the fight, would keep running despite harsh conditions, would probably keep them alive if hit, would be replaced quickly if destroyed. A Sherman tank commander, Lieutenant James Cooper, wrote in his memoirs, "We didn't love the Sherman because it was the best tank. We loved it because it was reliable. You could count on it. When you're fighting a war, reliability matters more than perfection. I'd rather have a good tank that always works than a great tank that breaks down." German tank crews after the war often spoke with respect about the Sherman, not because it was superior in combat. Most agreed the Panther and Tiger were better fighting machines, but because the Sherman represented something they hadn't achieved: perfect integration of design, production, and operational doctrine. A former Panther commander, Heinrich Bauer, wrote in 1970, "We feared Tigers because they sometimes broke down before reaching battle. We feared Panthers because they required constant maintenance. But we never feared Shermans breaking down. We knew the Americans would always have working tanks." That psychological advantage, knowing your equipment will function reliably, is worth more than armor thickness or gun caliber. Klaus Richter died in 1982 at the age of 90. He'd spent his later years consulting for German automotive companies, teaching engineering philosophy, and writing about wartime experiences. His papers, donated to the German Technical Museum in Munich, included the original report on the Sherman examination, 64 pages, technical drawings, photographs, detailed analysis. The conclusion, written in 1944, still resonates today. The American M4 Sherman represents not just a tank, but a philosophy. It is engineered not for individual excellence, but for systematic effectiveness. Every design choice prioritizes reliability, maintainability, and producibility. The result is a tank that is technically inferior to German designs, but operationally superior in every aspect that matters for sustained warfare. This is the lesson I take from examining the Sherman. In modern industrial warfare, the side that can field reliable equipment in overwhelming numbers will defeat the side that fields excellent equipment in limited numbers. Engineering excellence must serve strategic purpose. Otherwise, it is merely academic achievement with no practical value. The Sherman is not the tank I would have designed. It lacks sophistication. It lacks elegance. It lacks the technical brilliance that defines German engineering, but it has something more important. It works. It keeps working, and it wins battles through sheer operational persistence. That is worth more than all the sophistication in the world. Today, military engineers study Klaus Richter's Sherman analysis. It's taught at military academies worldwide. Not as a criticism of German engineering, German tanks were excellent weapons, but as a lesson about design philosophy. The lesson is simple. Design for the war you're fighting, not the war you wish you were fighting. Germany designed for tactical superiority. America designed for operational sustainability. Both choices were logical. But only one choice matched the reality of industrial total war. The Sherman wasn't the best tank in World War II. It wasn't the most powerful, wasn't the most heavily armored, wasn't the most technologically advanced. But it was the most practical, the most reliable, the most sustainable, the most producible, and in the end, those qualities mattered more than any technical specification. Klaus Richter understood that. He documented it. He tried to warn German leadership, but by the time he did, it was too late to change course. The Sherman had already proven its philosophy, not through technical excellence, but through operational persistence. And that persistence, that reliable, sustainable, practical persistence, helped win a war. That's the legacy of the Sherman tank. And that's the lesson Klaus Richter learned in a warehouse in France in July 1944. When he examined an American tank and realized his side had been engineering for the wrong priorities all along.